Hello, my name is James Pitts from Forward AM BASF 3D Printing Solutions. I'm going to be talking to you about our metal filament systems. First off, I'm an application technology manager at the Additive Extrusion Systems metal systems here at Forward AM, and I'm a mechanical engineer. And I joined B3DPS at November 2017. I'll go through the agenda real quick. We're going to introduce you to metal fused filament fabrication, or MF cubic. We're going to go over some of the unique value propositions of the material in the system and speak about some application examples. Lastly, some developments and upcoming events. So fundamentally, our metal filaments are a filament used for 3D printing systems from everything from your almost hobby level or advanced hobby level prosumer up to an industrial printer. So fundamentally, they're metal powder bound together with binders to create a filament. And this filament is designed to be usable with both direct drive and Bowden FFF printers. After a part is printed, we use a system called debinding and sintering, which removes the binders and sinters, producing a full metal part. So this technology was fundamentally created for metal injection molding about 30 years ago. So we have a lot of experience developing feedstocks. So metal injection molding is nearly identical to plastic injection molding, but in that case, again, like our material, metal powders are combined with binders to be able to form your part, followed by removal of the binders and sintering down to a full metal part. Okay, so we've specially adapted our feedstock for filamentation. There's a lot of work to make sure that this material works in as many printers as possible. Feeding systems, extrusion systems, like we said, direct or Bowden. A lot of work went in there to make it user-friendly for as many platforms as is possible. So if we look through the process overflow, this is the metal injection molding, where you use our feedstock, it's injection molded, and you create the green part. What we're providing is a solution to shorten this cycle by providing filament and a 3D printer. So there's no lead time, there's no mold, there's no reworking of molds, there's no mold making required. The lead time for a printer is getting it set up, heated up, and started. Once your green part is created or printed, it's sent in debinding. Now, debinding is a catalytic debinding process that removes the organic compounds, leaving mostly metal. So the result of this debinding would be your brown part. Your brown part is, again, kind of a spongy, but think of a metal sponge, where all the gaps were filled before with binder are now held together with some backbone polymers, but that provides stability for the sintering process. Sintering process is just conglomeration of material into a solid part through heat and pressure. And at the end, you have a final metal part that's a full metal. So what are some of the unique value propositions? Well, we like to consider this material, and it was developed to be a disruptor and a force multiplier. It's a disruptor because it has a low relative printer cost. It's an order of magnitude cheaper to buy a printer that can use this material compared to a laser or powder bed based system. It can also provide hollow structures that cannot be made in any other technology. So as you can see on the picture to the right with this chain, this linkage assembly, this is a fully movable part that was created. Now, if those top layers were covered and you couldn't see the cross pattern, there would be enclosed chambers. Other methods would leave powder inside those areas and have to be accounted for, have to be removed, blasted out, vacuumed out. We have the ability to make truly hollow structures that have no material inside and require no removal, thus providing us with an opportunity to make significantly lighter parts, right? Also, we have a multi-material printing ability. So many printers, as you might know, have dual extrusion or even filament changing systems or tool head changers. This provides a situation where we could use bimetallics or multiple materials in making our part. I like to say with like a samurai sword, you want the backbone of the sword to be ductile and resistant to shock, but the outside needs to be hard and able to hold an edge and very, very cutting edge. And this is a situation where we could produce a material or a device or application like that by taking advantage of the different material properties all in one combined situation or one application, which cannot be produced otherwise. And we like to say it's a hybridized first market advantage. So because this system works so closely with the metal injection molding, debinding, and sintering networks, we can enable customers to make their first version or their version 1 part or prototype, and knowing that future systems that could be metal injection molded are even better, but the lead time could be begun while you're already selling version 1 of your part. Kind of say there's no mold required, there's no lead time for printing. And another thing is, because this is a very new technology and there's a lot to optimize and to learn, we want to say that let the experts print for you and process it for you. So currently there's availability in Sculpteo in a beta program right now where you submit a solid model, some design checks are satisfied, and it is printed, processed, and returned, and usually with a turnaround time of 14-15 days. So that's kind of try before you buy. Or if you just need parts and you're not interested in you're only interested in the design and not the manufacturer, we can take care of that for you. Now, if you want to print it yourself and you want to take care of it that way, you would use our debinding and sintering. You're gonna hear DNS a lot, so we use DNS network. That's where you would print your part, mail it out to the network, and it would come back sintered. Now, this network is, again, created in metal injection molding, so we have large industrial solutions that have quality control standards used in automotive and aerospace and other technologies. So it's available both in North America and the EU, and we're currently developing in the Asian Pacific region. Okay, so let's talk about one of the examples. This is a bracket. You can see the round portion connects with the helper of a bar there, and this customer wanted to see the application in heavy device manufacturing, so they make specialty machinery. Now you can see these different designs here. Those are both for visual appeal, but at the same time, that provides a significant reduction in the weight. That makes their parts easier, more efficient. Now, if you imagine trying to make some of these structures with traditional methods, some could be possible, but very, very difficult. The one on the top right with the more flower-shaped infill, that's not possible in traditional manufacturing. It could be made in some other additive machines, but in this case, we used a Ultimaker S5. So price point of around 6,000 euro, you're up and running printing metal. And we use the 0.6 nozzle, so we could go a little bit faster. And the final parts go between 150 and 250 grams, depending on that infill structure, depending on the operational needs of the part. And the Sculpteo estimated price would be around 40 euros. So they're using this for jigs and fixturing also. They can kind of minimize the amount of material they're using and maximize performance and appearance. The next part we'd like to talk about worked with Liebherr Components and their special machinery. And this is a prototype development production using as a fixturing system for one of their components. And you can see here, although relatively simple geometry, this would still require advanced CNC as far as a multi-axis machine. And you can imagine, even if you're starting with an extrusion bar and then cutting away cutting away the material, you're still going to have to throw away a solid, 40-50% of stock material. Now, in our case, we were able to reduce that by not needing it. You don't need to throw away the material because you're not subtracting it away. You're only adding it to it, and at the same time, the actual component itself weighs 50% less. Right? We were able to do enough design changes that even the part itself is reduced by 50%. As you can see here, some of the teardrop and overhang structures were optimized for 3D printing. Again, we used an Ultimaker S5 with a 0.6 millimeter nozzle. And we get about 40 euros for this part to be made. Now, this provides, as we said, flexibility and design adaptation. This is something they can do in-house. They can make a couple of different prototypes. They can test them. They can look at them and then send them in for debinding sintering. In fact, they can make 5 different types, center them, bring them back, and then see which one they like the best. It kind of uses a free-form way to integrate kind of the aid in production, at the same time kind of let the designers and the material scientists explore different applications. Okay, and now our newest material is going to be 17.4 pH. It's a precipitation hardened steel. It's highly heat treatable for levels of strength and hardness, and it's corrosion resistant. So it's widely applied in the aerospace, chemical, industrial applications. Now it's most fitting for high wear applications at temperature. So this will hold its mechanical properties, creep reduction, things like that, up to 300 C. And this is going to be in a test marketing phase. It's going to begin this summer. Okay, first I want to kind of, again, talk about how the two systems work. Now, you can buy the filament from one of our distributors. You get a coupon for debinding and sintering. Once you've printed it yourself, you can send it off to our network and schedule for debinding and sintering. They sinter the part and it returns back to you. Our other option, of course, is Sculpteo, which is currently in a beta program, which is even faster. You upload a file, and everything's taken care of for you. 14, 15-day turnaround, parts are sitting at your home or at your desk, and you can start using our material. And this provides kind of a try before you buy. If you want to just see what's possible, what ideas you might have without expending too much resources and time printing, or if you're new to printing and want to just see how it works once you learn how to print, which is, again, very easy, you can go ahead and use our platform. In addition, for those for designs and setting up of the process, there's full documentation on design guidelines, process guidelines, and other examples to help you learn. One, say, post-processing. Here you see kind of what it looks like before polishing. That's what it's going to look like out of the oven, and then a simple polishing process, just to kind of give users and designers an idea of what to expect and how to best use this material. Okay, so in conclusion, we want to say in the office or at home, manufacturing industrial parts is now possible. We are now able to make highly complex parts in orders of magnitude cheaper capital investment for printing, making things at CNC milling, laser sintering, binder jet, laser cutting, other options, both some could not even be made. And if they were an equal design that both could make, we're significantly less requirements for capital and resource. Another thing is there's no significant investments required. Not only is the printer much cheaper, the processing network is external, so those can be done. You don't have to buy all that system and all the heat treating and those things. They can be sent to a service and it comes back. Same type, if you want to do it even easier, using a benchmark or small series part production can be done with our Sculpteo platform. And just kind of to wrap it up here, some of the pros and cons. Well, we have freedom of design according to debinding and sintering requirements. Like any other technology, this filament and the parts we make with it have certain requirements to help it be best optimize your part, features that can best optimize the part for your application. All right, with the external post-processing and long lead times, you can do it all in-house. If you want it to be completely controlled, it's all in-house, or you can do it kind of a la carte. You can just print it, or you can have use Sculpteo, or we can have the debinding and network, or we can get you in contact with a service provider. There's many different steps you can do this here. Now, like anything, there's a learning curve for the first time, and that's where it is a complex technology. That being said, we've tried to make it as easy as possible to use, using FFF, first of all. Second of all, having external processes, and of course, design and process guides. Okay, well, I'd like to thank you for your time, and I appreciate it. If you have any questions, let us know. Thanks, and have a good day.